Alright, so far in the trigonometry that we've done, we've talked about right triangle trigonometry. So whenever we use sine, cosine, or tangent, we've always made that rule that we had to have a right triangle. But sine and cosine can also be extended into non-right triangles that we're working with to find sides and angles. And when we do that, we usually deal with the law of sines and the law of cosines. So today that's what we're going to start. So this should be in your trig book. Make sure that you go to your table of contents and write out this line is titled Law of Sines and Law of Cosines. The spread number depends on whatever your previous spread was, whatever's current in the class. Each year I add and subtract things and topics from our trig books, so this spread may be different from year to year, so just add that in there to wherever we currently are in the book we're making. So the law of sines is what we're going to start with here. So as we do this, make sure that you're copying down this like we do in class with the notes. And suppose we have triangle ABC here. And I say triangle ABC, we're talking about the capital letters. That's the vertex of each angle here. So the capital letters are referring to the actual angle measure. The lowercase letters refer to the side length. And notice the lowercase a is across from capital A. The lowercase b is across from angle B, and the lowercase c is the side length across from from capital C there. So whenever we're dealing with law of sines and law of cosines, we'll use these letters so we can easily see if we're talking about the angle, it'd be a capital letter, or a side length that's across from that angle, it'd be the lowercase letter. So law of sines starts with this. It says, suppose you take the sine of angle A and put it over the side length that's across from it, then that will be equal to the sine of B, angle B there, across from the side length B there, and that's going to be equal to sine of C across from or over the side that's across from angle C. So I've got three fractions here, and I want you to notice that on the top you're taking the sine of the angle, and on the bottom, the denominator here, you've got the actual length of the side across from that angle. So typically when we do a problem, we don't have to write out all three fractions. We're only going to deal with one of them. So suppose we don't know what C is, lowercase or capital C, and we don't really care, then you just kind of cover that part up, and we're just dealing with an equation that looks like this. And basically, in order to solve for one of these variables, you need to know three of the others. So if you knew angle A's measure, side A, and side B, you could figure out angle B, even though it's not a right triangle. So, but in general, this is what you should have for this law of sines. And the law of sines is actually a little bit easier to remember than the law of cosines. Let's look at an actual example, because that will make it a little bit easier to, you'll see how easy this actually is. So suppose we have this triangle right here. Now, 93, 48, 39, those are the angle measures in the triangle. So the problem's given us all three angles here. Notice it's not a right triangle. So that throws out using our basic right triangle trigonometry that we've already learned. It also throws out Pythagorean theorem, because we've got to have a right angle to use Pythagoras. Not to mention, we only know one side, so we couldn't use Pythagoras anyway. So for this, if I'm going to solve for side length A and side length B, I'm going to use the law of sines. And let's say I want to solve for A first. Well, then I take the sine of 48. Notice that is the angle that is across from side length A. So the sine of big A over little a, that's my unknown. And I want you to try to fill out the rest of this equation before I show you the answer here. So what would that be equal to? Now, notice we don't want to include B on this, because if we include B, we don't know what B is. So if I say the sine of 39 over little b, well, that doesn't really help me out much, because I end up with an equation with two unknown variables in it. So I'm going to take the two sides, the side and the angle that I do know, the sine of 93, and put that over 15. So that's what our equation starts off looking like. And from here, since I have two fractions that are equal to each other, then I can cross multiply and solve from there. So cross multiplying, I get 15 times the sine of 48 is equal to a times the sine of 93. And then I'm going to divide both sides by the sine of 93. So I end up with a is equal to 15 times the sine of 48 all over the sine of 93. And you can punch that in your calculator. When you do, let's see, you should get I got 11.2 here. So A is equal to 11.2. Oops, I lost my pen tool. Now, for the next one, I want you to set up, pretend like we don't know what A is, and set up an equation to solve for B. So hopefully you paused the video and did that, and this is the equation you should have gotten. So I can use the same ratio right here, the sine of 93 over 15. That's equivalent up in the top right hand corner of saying the sine of c over little c. And then the sine of 39 over little b here. Cross multiply and solve. And I want you to pause the video and see what you get there. And if you did it correctly, let's see, you should get b is equal to 9.5. B is equal to 9.5. All right, so I'm going to give you some more examples here in a moment. We'll look over, make sure that you've got the law of sines down, but that's pretty much it, and we're going to move on to the law of cosines. So for the law of cosines, sometimes the law of sines, we don't have enough information to do a law of sines. If I had a preference, I would always want to do the law of sines. You're going to see why here in a second when we look at the law of cosines. But sometimes there's just not enough information, and so we have to revert back to the law of cosines instead. So once again, we've got that same triangle there. It's marked capital A, capital B, capital C. The lowercase letters are referring to the sides across from those capital angles there. The law of cosines says this. It says a squared is equal to b squared plus c squared minus 2bc cosine A. So that can look a little bit crazy, and this is something you've got to remember. But here's how I kind of remember it. It kind of looks like this first part. If we cover up this portion right here, it kind of looks like Pythagorean theorem. But remember, we're not dealing with right triangles here. They can be any angles in there they want to be. But then the rest is you got to subtract 2bc times the cosine of A. Now that's not all the law of cosines. So we've got some other portions to it. I'll go ahead and show it to you. You got all of that. So when you're just presented with all three lines there, that can look very daunting, but under closer inspection you realize it's all the same equation. It's just written differently there. Notice this is solved for little a squared. This is little b squared, this is little c squared. When a is over here, b and c are being squared and added up on the right. B is over here, the other two sides are being squared and added up. C's by itself squared, the other two sides there, a and b, are squared and added up. So there is a pattern here, and I want you to not, like I said, be overwhelmed. So once again, let's look at it. If a is by itself, a squared is by itself, you got b squared plus c squared. And then notice you got minus 2bc. See the b and the c here? If a and c are here, you got minus 2ac. With a and b right here, you got minus 2ab right there. And then lastly, it says the cosine of big A. Notice that corresponds to the little a right here. When you've got little b right here, on the end you've got the cosine of big B. When you got little c right here, you've got the cosine of big C. So one more time, look at it. You've got when a is by itself, you take the other two sides and square them, add them up. Then you subtract the other two sides times 2. And then the cosine of the angle that's by, or the side that's by itself over here, the angle that corresponds to that side. Same thing right here. B is by itself, b squared. You got the other two sides, a squared plus c squared minus 2 times the product of the other two sides, A and C. So notice B is nowhere in here except for on these two ends. Down below, C is on the ends alone, except for you got big C there, little c right here, and then everything on the inside is just dealing with the other two sides. So if you take some time and work out these problems, each time you try the problems, don't just go back and look at the formula. See if you can remember the formula. If you do that little bit of practice, it saves you a lot of tough memorization and a lot of questions on the quizzes and tests up ahead. So that's our law of cosines. Let's actually see how that looks in a problem. Now that you see those equations, you probably tell why I'd rather do the law of sines. So suppose we have this right here. Here's a triangle and it says find the value of B. Let's first approach this and say, you know what, I love the law of sines. I don't want to do this junk in the law of cosines. Let me just try doing the law of sines on this. So if we were to do the law of sines, well, you'd say, okay, I know this angle. Sine of B I know. That's the same thing as the sine of 44. I'm going to put that over little b. That must equal the sine of an angle here. I don't know what C is. I'm just going to put the sine of C, that's big C, over 10. Well, the problem is I have two unknowns. I've got a C right here and I've got a B right there, so I'm not going to be able to solve this equation. There's no other information here that I could use. If I tried using angle A, I'd end up with capital A right here and 22 on the bottom. Same problem. I've got an unknown here and I've got an unknown right there. So here's a case where I cannot use the law of sines. I've got to use the law of cosines. So I want you to take a moment, pause the video, and try to use the law of cosines here. Pick one of these equations. They're really all the same, but if you're going to keep them using the same letters, go ahead and try to do that now. I'll pause the video and write it out myself, so pause it and then come back once you think you've got it. Alright, so you should have had something that looked like this that I've got written out in red down. So I chose, and this is kind of like using the second equation right here, although really you only got to memorize one and then switch around your letters when you need to. But b is the side I want to know. So I've got b squared, and what I've got written in here in green, I've underlined it in green so we could quickly look at this and see that everything that's green is corresponding to b, either little b or capital B. So going back to the law of cosines, capital B is the angle that's across from little b. So I know that the angle across from little b right here is 44. So I'm going to, over here on the end, I'm going to write out the cosine of 44. My unknown is b squared. The next thing in my equation is little side a squared. Well, little side a is 22. The big A is really not needed in this problem. So you only see a showing up as 22. So going back to the equation, you got a squared right here. This is going to be c squared. Notice I've got c as coded as blue. And I'm not expecting you to color code this every time, and I won't color code it every time. This may be the only time I do, but since this is such a long equation and your first time substituting it in, I just color coded it for those that it helps. So I've got a squared plus c squared minus 2. Remember, that's part of the equation up here, this 2. Then it should be a times c. So a is 22, c is 10. Remember, these are all lowercase letters in the equation, so they should all be side lengths. If I knew the value of these angles, I wouldn't want to put those into this equation here. And then minus the cosine of, not minus, but times the cosine of 44 right there. So I want you to go ahead, now that I've pretty much done all the grunt work for you there, as far as coming up with the equation and substituting in, I want to see if you can correctly put this in and into your calculator and solve it. So pause the video, solve it for B. It's just all algebra skills here, and then come back and check to see if you got it right. Alright, and if you did it correctly, you should have gotten B is equal to 16.4. Now, if you did it incorrectly, I want you to go back and try it again. This time I want you to pay attention. Remember, I said it was all algebraic. I want you to pay attention to the order of operations. notice that when you look at these equations, you've got a plus symbol right here, a minus symbol right here, and then inside of in between each one of these is a multiplication symbol. Remember, please excuse my dear Aunt Sally, we do parentheses and then multiplication and addition from left to right first. So we want to multiply this mess first. So anytime I do this, I always take this whole glob, multiply it first, and write down my number right there. And then I do a squared plus c squared, and I write down that number right here. And then I subtract the two. So do that first, pause the video, and try it out again, see if you get 16.4. Alright, so looking at this, and this is kind of with my work done now, this first section right here, 22 squared plus 10 squared, I got 584. And then remember, this has to be done first. We're not going to just subtract 2 from it, from 584, and then complete this. We have to do order of operations. So 2 times 22 times 10 times the cosine of 44 gives me 316.51. Now I can subtract all of that and do 584 minus 316.51. That gives me 267.49. So that's not my answer. That would be a really long side, by the way, if you stop there. In fact, we know from other things we've done in geometry this year that if you accidentally left this as your answer, that two sides of a triangle have to add up to be larger than the third. And so 10 plus 22 is not bigger than 267. So remember, we got b squared right here. So the opposite of squaring it is to take the square root. We square root this side. That means we have to square root this side. And then that leaves us with, once we round to the nearest tenth, 16.4 on the right there. Okay? Let's try some examples. So copy this example into your notes, and then I want you to pause the video and try to find the value of x. First, when you look at this, say, the first question is, should I use the law of sines, or can I use the law of sines, or do I have to use the law of cosines? And so we prefer using the law of sines, and sometimes with problems we'll use the law of cosines, and then we can finish the rest of the problem and the rest of the unknowns using the law of sines. But that's the first thing we should try, is see if we can use the law of sines first. So pause it, and then try it out. And so hopefully you see here that we can use the law of sines to figure this out. So I'm going to say that the sine of 35, put that over the side across from him, which is x, is equal to the sine of 48 over the side across from him, which is 28. And the rest is just cross multiplying and solving. So 28 times the sine of 35 is equal to x times the sine of 48. And from here I can divide both sides by the sine of 48, and you get x is equal to 28 times the sine of 35 divided by the sine of 48. So make sure you can punch that in your calculator. You should be in degree mode. Hopefully you are, since you've been doing everything else in this video. And see what you get for your answer. And after punching all that out, I got x to be 21.6. I'm just rounding to the nearest tenth today, so 21.6. All right, let's try, whoops, showing you all my personal information there. Sometimes the Mac does that. I know everybody loves seeing my desktop. Try out this one. So you should have the video paused. Try it out. Once again, this is one that we can use the law of sines on. So we can say the sine of 22 over 18 is equal to the sine of 104 over x. Cross multiply to solve, you get x times the sine of 22 is equal to 18 times the sine of 104. I know I'm writing kind of small there, but if you're listening to the audio, you should be able to get it. divide both sides by the sine of 22. I'll write this one a little bit larger. 18 sine of 104. Divide it by the sine of 22 is equal to x. And when I punch this in my calculator, I just punch the numerator in first, hit enter, and then I hit divide by 22. So in the calculator, I do 18 times sine 104, hit enter, divide by the sine of 22, and I get 46.6. And this is degrees. No, not degrees. This is a side length. So we actually don't have any units on this. So if it had units, we'd put those units with it. All right, let's try out another one. So once again, determine should I use law of sines or law of cosines for this. And this is one where we can use, once again, law of sines. So I'm keeping it easy for you right now. So I'm going to say the sine of 34 over x is equal to the sine of 56 over 19.1. Cross multiply and solve. 19.1 times the sine of 34 is equal to x times the sine of 56. And so we're going to divide both sides by the sine of 56. And I'm sorry, I'm writing like first grader here. Sometimes my tablet makes me look like that. I promise in real life I have better handwriting. So in the calculator, punch in 19.1 times sine of 34. That gives me 10.7, and then I'm going to divide it by the sine of 56. And that gives me 12.9 when rounded to the nearest tenth as your answer. All right. See if the next one's got cosines for us. So on this one, once again, if I try to use the law of sines, I get the sine of 89 over x, nothing wrong with that, is equal to the sine of what? U over 15, or the sine of t over 14. Well, I end up introducing another variable, and we can't have two variables in an equation. So here's a case where we're going to have to use the law of cosines. So see if you can write out the equation, and then unpause it, and see if it matches my equation. Alright, so x is the side we're wanting to know. And so I'm just going to put that guy by himself, x squared. And I'm going to say that is equal to, well, I'm using x here, so it's going to be the other two sides squared and added up. So 14 squared plus 15 squared. And then looking back, we're going to say minus 2 times the product of these two, times 14 times 15. And then times the cosine of the angle across from x, which is 89. So that's the way I kind of memorize the law of cosines, because otherwise I get too confused in trying to memorize all three of those lines. I just simplify it by saying this is the side I want to know, square it. Now everything in the middle here is dealing with the other two sides, which hopefully you do know. And then the last one is the cosine of the angle. Now sometimes we do law of sines, and law of cosines, we'll see this as we do more examples. We'll need to know this angle, and that's okay. Sometimes you'll know all three sides and you're trying to figure out that angle, and you can do that as well. So anyway, let's go ahead, pause the video again and see if you can solve for x, and then come back and see if it matches my answer. And so for my answer, I got 20.3 is the answer. And so once again, remember, do this in parts, because if you don't follow the order of operations, you're going to get it wrong. So I said, okay, what is all this mess multiplied? I got 7, it says 733, it should be 7.33. And then 14 squared plus 15 squared is 421. And then that's when you do your subtraction in the middle here, and you get 413.67. But that's equal to x squared. We want to know what x is, so square root both sides. and I get x is equal to 20.3. Right there is my answer. So those are the 4 examples you should have in your trig book along with your notes. And then to finish it out, I want you to open up your textbooks. I want you to try page 523, numbers 3 through 14. Make sure you copy the problems. And so that's drawing out the triangles and what those problems are. That way you've got them in your trig book forever. I want you to show your work, so I know you're not just Googling answers. And I want you to circle your answers in the back of your trig book, okay? All right, I hope this helps. Make sure you ask me if you have any questions, and have fun doing those problems.